Hello everyone, I am going to present about the topic how HTTPS secures the internet. The internet is not secure by default. When we browse websites, especially for banking, shopping, or emails, our data can be easily intercepted. That's where HTTPS comes in. It is simply the secure version of HTTP. That is, it ensures that our communication with websites is private and trustworthy. Let us look into what is actually HTTP. HTTP stands for Hypertext Transfer Protocol. It is the basic protocol that allows communication between the web browsers and the web servers. It works on a simple request response model. When you type a website address in your browser, the browser sends a request and the server responds with the web page. HTTP works at the application layer of the OSI model and it usually runs on port 80 by default. However, the main problem with HTTP is that it sends data in plain text. This means there is no encryption at all. For simple browsing, this might be fine. But if you're sending passwords, banking information, or personal details, anyone who intercepts the communication can read it easily. So, HTTP is useful but not secure. That's exactly why HTTPS was introduced. Now, let us look into what are all the challenges we face in HTTP. First, data interception. On an open or a public Wi-Fi, anyone running a simple packet sniffer can read what is being sent, such as search terms, form inputs, and even session cookies. Second, identity theft. If you type a username and a password on a HTTP page, an attacker on the same network can capture those credentials and reuse them to log in as you. Let us take a real life example. Imagine logging into your email at a cafe using HTTP. A nearby attacker captures your login request on the Wi-Fi and immediately gets your email and password. Within seconds, they can access your account. That's how dangerous the plain text transport is. HTTPS is used to overcome this drawback of HTTP to make it more secure. HTTP stands for Hypertext Transfer Protocol Secure. It does the same job as HTTP, moving data between your web server and your browser, but it adds a security layer using SSL or TLS. With HTTPS, our connection is encrypted. So, even if someone intercepts the traffic, they see the unreadable ciphertext. It also provides an authentication, that is, your browser checks a digital certificate to confirm it's really talking to the legitimate user or site, not an imposter. And it ensures integrity, meaning the data cannot be altered in transit without being deducted. You'll use a site is a site is using a HTTPS when you see the padlock icon in the address bar and the URL starts with a HTTPS colon with a double slash and a dot. Typically, HTTPS uses port 443 and establishes a secure session key after a quick TLS handshake. In short, HTTP is like sending a postcard where everyone can read it. HTTPS is sending a sealed, tampered, evident envelope that also confirms the sender's identity. Now, let us take a look into how HTTPS actually works. First, it encrypts all the communication between your browser and the web server using SSL or TLS. This means every request that you make and every response that you get is scrambled and no outsiders can see it. It also uses something called as session key. These are temporary encryption keys generated for each browsing session. They'll make encryption faster and prevent attackers from reusing the old keys. With HTTPS, we get three main security benefits. Confidentiality. Outsiders cannot read the data. For example, if you type a credit card number, it is hidden from a prying eye. Second is integrity. The data cannot be modified during transfer. If attacker tries to inject malware or change what's being sent, HTTPS will detect it. Third is authentication. It verifies the website you're visiting is really who it claims to be and not a fake copy. It also protects against man in the middle attacks, where an attacker secretly intercepts communication between you and the server. Even if attacker captures your data packets and they see what is just an unreadable ciphertext, completely useless without the decryption keys. Now, let us take a look into the SSL or TLS protocol that is being used in HTTPS. SSL or Secure Sockets Layer was the older protocol for securing web traffic, but it's now outdated. The modern standard is TLS, Transport Layer Security, which is stronger and widely used today. TLS sits between the application layer like HTTP and transport layer like TCP. It provides three main protections: encryption, no data is hidden; authentication, to verify the secure identity; third is integrity, so no one can tamper with the data. TLS uses digital signatures from trusted authorities and a handshake process to establish trust and create encryption keys. It combines public key encryption for secure exchange with the symmetric keys for fast communication. The latest versions TLS 1.2 and 1.3 are what secure websites use today. Now, let us look into what this handshake that we are talking about really is. When you visit a secure website, HTTPS does not just start sending encrypted data right away. First, your browser and the server performs what's called a TLS handshake. There are four steps in it. First step is the client hello. The browser asks the servers for a secure connection and starts shares details like supported encryption methods. Step 2 is the server hello. The server replies with its own settings and sends a digital signature to prove its the identity. Step 3 is a key exchange. Using cryptography, both sides agree on a session key, which will be used for actual communication. And the last and the final step is once this key is encrypted and set, communication begins, meaning all the data between the browser and the server is now private and secure. Let us look into a quick comparison between the HTTP and HTTPS. With HTTP, data is set in a plain text. This means if someone intercepts the traffic, they can read sensitive details like passwords, credit card numbers, etc. It does not provide encryption, authentication, or data integrity. On the other hand, HTTPS adds a layer of security using SSL or TLS. All communication is encrypted, so no outsiders cannot read it. It also ensures authentication, which means the website you are visiting is the real one and not a fake copy. Plus, it guarantees integrity so the data cannot be modified during transport. Visually, the easiest way to spot HTTP is the padlock icon in the browser address. That padlock means your connection is secure. Now, let us look into the benefits and the challenges of HTTPS. HTTPS provides sensitive data protects such as passwords, banking details, and credit card numbers, keeping them safe from attackers. It prevents man in the middle attacks where attackers try to intercept and modify communication. It builds trust because when people see the padlock icon, they feel more confident and secure in using the site. And even technically, HTTPS improves SEO ranking in the Google, meaning secure websites are favored in search results. Now, let us look into the challenges. Web pages need a valid SSL or TLS certificate, which must be purchased or issued and kept up to date. If a certificate is expired or invalid, browsers display scary security warnings that drive users away. Also, in earlier versions, HTTPS was slightly slower than the HTTP due to encryption overhead. But with modern protocols like HTTP2, the issue is being largely solved. Let us look into a real life application of where the HTTPS is required. In banking, online banking, and shopping platforms like Amazon or PayPal, HTTPS is essential to protect credit card and payment information. For emails such as Gmail or Outlook, HTTPS ensures that our personal data and work communications are private and cannot be read by attackers. On social media platforms like Facebook and Internet, HTTPS secures login messages and personal details we share every day. And importantly, government and healthcare protocol. It also relies on HTTPS. Here, security is crucial because they deal with sensitive information like medical records, identity details, and official documents. Let's wrap it up. The internet by default is not secure, but HTTPS changes that. It ensures confidentiality, integrity, and authentication of our data. That's why it's widely used in banking, e commerce, email, social media, and even in healthcare. It builds trust with users and protects against attackers like man in the middle. Today, in HTTPS is no longer optional. It is standard for all the websites. And newer versions like TLS 1.3, it becomes even more faster and stronger for the future. Thank you for listening.